Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are H.A.S. Today we will be demonstrating the operational characteristics of common base amplifier. We will tell whether our amplifier is common emitter, common base or common collector by shortening capacitors and DC voltage sources and see which end is directly grounded. Here you see it will be BJT's base, of course, which will be directly grounded, so that's why it is called as common base amplifier. Common base amplifier input signal is given through the emitter lead of BJT, you see here, and its output is taken from the collector. As we can see here, the output of common base amplifier is in phase with the input voltage, as there, of course, common collector, or should I say it is emitter follower, and its voltage gain is same as that of common emitter. So without wasting our time, let's start. I have already made this circuit to tell you what it does, and I will make it again for you in this video. Click on this button, that is Run PSpice, and you will see the output versus input. We see here that input is shown by the green probe and output is shown by the red probe. Now in this graph, green is our input and red is our output. Red is almost in phase with that of a green, but there is a little bit tiny time delay between the input and the output, which should not be there in ideal case, but sometimes it appears or it comes. It doesn't matter. What we want to achieve is our voltage gain, which is the most important. So let's make it again. Let's file, create new project, name it whatever you like. I will name it 5-4. Okay, create a blank project. Okay, this window will appear. I have shown you in my previous video how to pick up the components by simply here, that is play PSpice components, and we will start making our circuit. That first thing is voltage source, that is AC DC pulse. I will take sine wave, I mean AC sine source, that is AC voltage source. Then next one, it will be DC voltage source. It should be inverted with positive upward and negative downward. Now resistors, you can rotate them by clicking simply R. This is the load resistor. Now we need the most important component, that is Npn transistor. This is our Npn transistor. Rotate it. Emitter should be towards the input side and collector should be towards the output sides. Now capacitors, place PSpice components, capacitors, discrete, passive. In the passive, their capacitors are present. You can pick them here or you can pick them directly from here. This is coupling capacitors C1 and this is C2. Now all I need is the ground. This is the PSpice ground. Simply join the circuit by using place wire. Make proper and neat modular circuit. it will be easy for you to understand, so try to make it neat. Now with voltage, here the DC voltage will be with other voltage. Now coupling capacitor, this is the second end and this is resistor. Now grounding the whole circuit. This is the most important connection, that we are grounding the base. So common base amplifier. Now we have to give them values to different components. Simply just double click on this window will appear. This will be 100 microfarad first coupling capacitor. Second coupling capacitor, it will be 2.2 microfarad. This is the R1, that will gonna be 5 kilo ohm. This is voltage, that is DC. Its value will be 2. This is second voltage source. Now V1, it will be 8 volt DC. Alright, now our AC source, its value will be V off will always be 0, always. Its amplitude will be 1 0. Its mean 10 millivolt. Frequency adjusting, that will be 100 Hz, I guess. Now you have to create the new simulation profile. Name it whichever you like. I will name it the same as that of my project or my circuit. It is 5-4. Create. These options become visible as you see. Now the voltage probe, this is the input size, this is the output side. Now run PSpice. This window will appear, that is simulation settings window. See? We can edit these simulation settings from here. That is run to time. I will adjust it 100 millisecond, and maximum step size, it will be 100 microseconds. Alright, now I will run it. As you see, the graph is in between the input and output. Green is input, red is output. We can make it more visible by keeping this R load small. It will be 100. Now again we will run. Yeah, now see that green is our input, red is output. From the graph it is clear, green is input, red is output, and you see that the red is greater in amplitude with that of a green and is in phase. That's all for today. That is common base amplifier. Thanks for watching, and don't forget to subscribe.
Guys, don't forget to subscribe down below, and also give this video a big thumbs up, and don't forget to comment. comment down below. The dark.